Chapter 5, Functions and Graph. Okay, this is lecture 1 of 4. Okay, the subtopic will be 5.1, Functions. So learning outcomes at the end of the lesson, students should be able to define a function, emphasize the concept of one-to-one and onto. B. Identify a function from the graph by using vertical line test. C. Identify one-to-one function by using algebraic approach or horizontal line test. We are going to sketch the graph of a function. So that will be for polynomials up to degree 3, such as piecewise absolute values of linear functions, reciprocal functions, square root functions with linear expression. So inside the square root will be linear, meaning power of 1. Here, power of 1. And state the domain and range of a function. So let's move on. Look at the table below. We have relations. So as an introduction, so let's define what do we mean by relation. A rule which associates each element of set A with element in set B. So domain will be the all elements in set A. Range, all elements in set B which are matched with elements in set A. Codomain, the whole elements of set B. Okay, there are 4 types of relation. So as you all know, so the first will be one-to-one, one-to-many, many-to-one, many-to-many. So how do we differentiate among 4? So one-to-one, definitely it's clearly stated that can clearly say one-to-one, one-to-many. So here 1y onto 2 and onto number 7. So one-to-many. So many-to-one. So Z and P mapped onto 3 and many-to-many, this is Rojak. Right, next, look at page 2. So we have functions here. So a function is a relation from set A to set B such that every element in set A is matched with only one element of set B. So functions are only for 2 types of relations, so which is one-to-one and many-to-one. So again, so f is a function from A to B, is a mapping from set A to set B. So can be written as f of x onto y, so fx equal to y, where x is the object and y is the image. So look at below the next part, we have here a function is onto. The word onto is very important if range equals to its codomain. So if you look at the diagram here, the bin diagram, so let's say this is your set A, so this is your set B. So elements of set A is the domain, so we have P, Q, and R here. And we have codomain, all elements in set B, 2, 4, 6, here, codomain. But the range is the values that we get under the function. So when we mapped from set A to set B, so we have only 2 and 4. So is this an onto function? So the definition of onto is here, if the range equal to the codomain. So as for this example, the range is not equal to the codomain, hence it is not an onto function. Okay, let's move on to example 1. Okay, so if set A with elements 1 to 4 and 1 to 3, and B 4, 5. So the function 1 to 4, so let's do the bin diagram. So that is your A. Okay, pardon me with my sketching. So as long as you can understand it, even though it looks ugly. 1, 2, 3. So here 4 and 5. So 1 to 4, 2 to 5. Okay, 3 to 5. So what types of relation is this? This is many to one, isn't it? So this is many to one. So is this a function? Many to 1? Yes, it is a function. Okay? So show that it is an onto function. So again, so we have our domain. So write down our domain. That will be 1, 2, 3. So our range will be 4, 5. So our codomain will be 4, 5. Isn't it? Okay. So hence, we can see clearly here, range equal to the codomain. So hence, conclusion, f is an onto function. Right? Onto, okay. Example 2. State whether the given function is onto or one-to-one function. So given that function f from real to real and defined by the function fx equal to x squared. So we have f real to real. So meaning here the domain is real number. So the codomain also real number. Okay, we have the function fx equal to x squared. So let's choose values of x from real number. So it can be any values. So let's choose x equal to 1. So let's say f1 equal to x squared. Oh, sorry. So that will be negative 1 squared. So you get 1. So x is 0. So f0 also 0 squared. You get 0. So x negative 1. So f negative 1 squared, f negative 1, so you get negative 1 squared, you get 1. So x, let's say 2, so f2, you get 2 squared, for x negative 2, so f negative 2, you will get negative 2 squared, which is 4, etc., etc. Okay, so from here we can see that, so f1 you get 1, f negative 1 also you get 1. Okay, so this is many to 1 function. So hence f is not one-to-one function. Okay, so range of f, that will be 0, 1, 4, etc., etc. So this is not real number, right? So meaning it is not equal to the codomain. So conclusion, hence f is not onto function. So next, determine whether a relation is a function. So by using the vertical line test. So here vertical line test. If any vertical line drawn vertical intersect the curve y equals to fx only at a point, then fx is a function. So example 3. So state which graph represents a function below. So a fx equals x squared bracket 2 minus x. So this is a cubic curve, cubic function. So draw a vertical line anywhere. So it cuts at one point. Hence, it is a function. So similarly for the rest. What about this? Function. Okay, C. Draw a vertical line. So it cuts at 2 points. 2 points. So not functions. So here, function. Okay. So next page. Determine whether a function is one-to-one. So a function can be determined whether it is a one-to-one by using graphical approach, or that is the horizontal line test or the algebraic approach. So now we're going to use the horizontal line test. Okay, horizontal line test can be used to determine whether a function is one-to-one. So just now, whether it's a function or relation for the vertical line test. For horizontal, one-to-one or not one-to-one. So if a straight line drawn parallel to the x-axis cuts the graph not more than once, so it is a one-to-one function, meaning only 1 point. Okay, so horizontal. So identify whether each of the following is one-to-one. So draw there 2 points, not one-to-one. Okay, not to one function, right function there. Okay, so here, everywhere it cuts at 1 point, so one-to-one function. So C, this also 1 point, cuts at 1 point, so one-to-one function. So here, it cuts at 2 points, so not one-to-one function. Right, next, we're going to show whether a function is one-to-one by using algebraic approach. Okay, a function f is said to be one-to-one if f of x1 equal to f of x2. Here, only when x1 equals to x2 for each x1, x2 elements of the domain of f. So let's look at the processes. Look at example 5. Okay, so a fx equal to 2x plus 3. So the first step will be let x1, x2 elements of the domain. So we have f x1 equal to f of x2. So you just need to substitute into the function given. So we get 2x1 plus 3 equal to 2x2 plus 3. So this 3, bring it to the right side. So bring it here. So we have 2x1 equal to 2x2. So divide by 2. So x1 equal to x2. So statement. Hence, okay, fx is a one-to-one function. Similarly for b, so again let, okay, x1, x2 elements of the domain of G. So the function here is G. So of course domain of G. Don't put F instead here. So meaning we have G of x1 equal to G of x2. So x1 cubed plus 12 equal to x2 cubed plus 12. So we can eliminate the 12 here. Okay, so we're left with x1 cube equal to x2 cube. So this cube, bring it to the right side, becomes the cube root. So we get x1 equal to x2. So again, gx is a one-to-one function. Right, look at C and D. So if you notice, both are quadratic functions. The difference will be here nothing, here you have the x greater than -6. Alright, so first things first, we need to use, we need to do completing the square. So fx, so this is also x. So the fastest way is bracket squared minus bracket squared. Similarly here, bracket squared minus bracket squared. So half of 6. So x plus 3 minus 3. Here, half of 12, x plus 6 minus 6. So we end up here for C, x plus 3 squared minus 9. For D, we have x plus 6 squared minus 6 squared is 36. Okay, we do C first now. So let x1, x2 elements of the domain of f. So f of x1 equal to f of x2. So substitute into the completing the square form. So we have x1 plus 3 squared minus 9 equal to x2 plus 3 squared minus 9. So minus 9, done. So we are left with the x1 plus 3 squared. So here x2 plus 3 squared. So this squared, bring it to the right side, becomes square root. So we are left with x1 plus 3 equal to x2 plus 3. No, we have the plus minus. Whenever we have square root, there will be plus minus square root of something like this. Okay. So we have x1 plus 3 plus minus of x2 plus 3. Here is the intersection point, the turning point. So we have x1 plus 3 equal to the positive 1, so x2 plus 3. Or we have x1 plus 3 equal to negative of the x2 plus 3. So what do we get here? We have x1 equal to x2. But here x1 equal to, that will be what? So negative x2 minus 6. So we have the x1 onto two values. So statement, hence x1 not equal to plus minus of x2, meaning two values. Hence fx here is not one-to-one function. Okay, what about D here? So similarly, so we get to let x1, x2 elements of the domain. So similarly, f of x1 equal to f of x2. So can you see here? Same format of doing it. So just substitute into the completing the square form. Okay. So we have x1 plus 6 squared minus 36 equal to x2 plus 6 squared minus 36. Again, negative 36. Bring it to the right side. So we can eliminate these two. So we get x1 plus 6 squared equal to x2 plus 6. Again, so now squaring. Bring it to the right side, becomes square root. So again, x1 plus 6 plus minus square root of x2 plus 6 squared. So here, the square root and the squared, that will eliminate each other. So we have x1 plus 6 equal to plus minus of x2 plus 6. But we are given here the x, meaning greater than negative 6 only. So we have only the positive part. So x1 plus 6 equal to plus of x2 plus 6. Okay, so hence x1 equal to x2 only. Hence our conclusion, okay, fx here for D is a one-to-one function. Is it okay, everyone? Okay, look at D. So we have fx equal to modulus of x minus 1. So by definition of modulus, we know that modulus x is square root of x squared. So similarly, modulus of x minus 1, that will be square root of x minus 1 squared. Alright. So let x1, x2 elements of the domain of f. So we get f of x1 equal to f of x2. Okay, modulus of x1 minus 1 equals to modulus of x2 minus 1. Okay, by definition, so square root of x1 minus 1 squared equal to square root of x2 minus 1 squared. So eliminate the square root. So we're going to squaring both sides. Okay. So x1 minus 1 squared here, square root of x2 minus 1 squared here. So we are left with x1 minus 1 squared, square root, no more square root. So we get x2 minus 1 squared. So again, bring the square here to the right side. So we get x1 minus 1 plus minus of x2 minus 1. Right, as just now. So meaning we have x1 minus 1 equal to x2 minus 1, so x1 equals to x2, or x1 minus 1 equals to negative of x2 minus 1. So we have x1 equal to negative of x2 plus 2. So hence fx here is not one-to-one function. Okay, let's look at E. So this is a third graph. Okay, you are given here, this is important. So this is actually the domain. This is the domain of f. You're given already. So this is from -2 to infinity. So let x1, x2 elements of the domain. So f of x1 equal to f of x2. So square root of x1 plus 2 equal to square root of x2 plus 2. So to eliminate the square root, squaring both sides. Okay. So here x1 plus 2, square root of x2 plus 2. So we are left with x1 plus 2 equal to x2 plus 2. So that should be a plus minus. But we know that x greater equals to -2. So hence x1 plus 2, we have the positive only. Okay, so we have x1 equal to x2. Hence, okay, fx here is a one-to-one function. Right, basic shape graph of a function and finding the domain and range. Okay, so what is domain? Domain denoted by df is a set of values of x, okay, for which the fx is defined. Some functions defined for certain values of x only. Right, range, okay, we write it as rf, set of all possible values of fx. Domain and range of function can be written in the form of sets or interval notation. So what do we mean by set? You've seen this from the first chapter, interval notation. Alright. Okay, there are two methods to find the domain and range. That is by graphical and algebraic. So we are going to do graphical first. So for the first lecture, we're going to do the graphs up till the third function. So please bear with me. Okay, so domain of a function, starting and end values of x. So let's highlight this. Range, starting and ending values of y on the y-axis, here on the x-axis. Okay, if you look at the third function here as an example, alright, so this is the curve, okay, this is the curve. So from where the curve starts? The curve starts from here. Let me find, let's say blue, okay, so starts from here up to here. So the domain starts from this value, which is c, up to infinity. So in interval form, so this is half open, c to infinity, and the range from d, the corresponding value when x is c, the y value is d. So starting from d to infinity. So that's how we do it. So you need to be able to sketch the curve. Similarly, so this is a negative curve. So domain from c to infinity. So range from into negative infinity up to d. There you go. Okay, as an example. Okay, let's move on. So reciprocal function. Similarly, so this will be the vertical asymptote. Right, the horizontal asymptote comes from here. This is the horizontal asymptote. Right. Similarly here, so this is the horizontal, this is the this is the vertical, this is the horizontal. Okay, so constant and linear function. So now let's look at the constant and linear functions. So my question, do you know how to sketch for the constant and the linear function? So steps to sketch linear graph. First, you need to get the x-intercept, that is when y is 0. Find the y-intercept when the x is 0. Just need to plot the points and then just, okay, join the 2 points. Joined, miss the t there. Okay, example 6. Okay, look at example 6. Sketch the graph and state the domain and range for each equation below. So A, y equal to 5. So label the axis x and y first. This is the value for y. Find your y. This is 5. So y equals to 5. So all y. So will be something like this. How do I know? Let's say point here. So let's say this is 6. So this point is 6, 5. Here, that will be, let's say this is 2. This is 2, 5. So along the line, it is, you get the value of the y will be 5. Okay, so this is the origin. So hence, state the domain. So domain and the range. So if you look at the domain, so you can get lots and lots possible values of x. So I would say the domain here will be real number. What about the range? The range always be 5, isn't it? So here 5. So if I have another point here, let's say -3, also 5. So always 5 for the y. So the range will be 5. So in set form, because there's only one value. Alright? Right, similarly for B, so label the x and the y-axis and the origin. So this is value for x. Find your x4. So that will be the line. You can see that. Okay, what is the domain? Domain, what is the range? Give a good guess. So range, you have different possible values of the y, isn't it? Here different y, here different y. So I would say that the range will be real number. What about the domain? Domain, there's only one value here. It doesn't move. It doesn't go to the right. It doesn't go to the left. Only on the line. X equal to 4. So domain will be 4. Can you follow? Right, let's look at C. Okay, now you have y equal to 4x plus 3. So here, find the intercepts as the steps just now. So when x is 0, so substitute y equal to 4, 0 plus 3. So you get 3. When y is 0, you get what? 4x plus 3 equal to 0. X equal to -3 over 4. So the value of the x is -3 over 4. The value of the y is 3. Okay, we're going to join these 2 points. Okay, use your ruler. Okay, something like this. Alright, so it goes on and on, upwards, go on and on, downwards. So there's no values of x given. Okay, so I would say the domain here will be real number. Okay, also can be written as -infinity to infinity, and the range also will be -infinity to infinity. Right, for part D, so for part D, we have the values of the x here. So x will be in between -2 and 2 only. So let's prepare the axis. So label the x-axis, the y-axis, and the origin. Find the respective values when x is 0. So y equal to 2 minus 2 times 0. So we get 2. So that will be your y-intercept. Okay, when x is 0, when y is 0. So you get 2 minus 2x 0. So you get x equal to 1. Okay, so this is your 1, this is your 2. Okay, when x is 2, so you get your y to be 2 minus 2 times 2. So you get negative 2. Okay, here negative 2. When x is negative 2, so your y is 2 minus 2 times negative 2. So you get 6. Right? So let's sketch it. Use your ruler. So somewhere, something like this. So this is your 2. So this is negative 2. So this is your negative 2. So somewhere here you get 6. Okay. So pull up your y-axis. So this is your 6. Alright. So the domain between negative 2 and 2. So close interval negative 2, 2. So range between, so you get negative 2 here. The smallest value on the y-axis will be negative 2 and 6. Right, quadratic functions. So these are the tips. Okay, so let's say in general, if you have the function, the equation will be ax squared plus bx plus c. So as you all know from previous knowledge, so if your a here is positive, you have the smile curve, the smiley face. If you have the a to be less than 0, you have the sad face, isn't it? Right, the steps here to sketch: do completing the square, get the maximum minimum point, find the x and the y intercept. Then only we can get the range. Alright, so set to go. So look at example 7. So you look at this equation. So 3x squared. So that is a positive curve. So expect the expected. So that will be a smile. So here negative. So sad curve, something like that. So just prepare it. Okay. So plus 1, the graph is shifted upwards by 1 unit. Okay. So the graph will be when x 0, let's say if x 0, so y you get 0, except y equal to 1. So this is your 1. So the graph will be something like this. So label your axis. So this is your y equal to 3x squared plus 1. So this is your origin. So the domain will be real number. So negative infinity to infinity. So range, that will be from 1 to infinity. So always if you have infinity, it should be the curve beside it. Okay, let's look at B. Okay, so this is a set curve. So x 0, so get y negative 1. So this is your negative 1. So pull down the curve. Whoops. So let's do it again. So this is your negative 1. So the x-axis, the y-axis, the origin. Okay, so the domain will be a real number, or negative infinity to infinity, and the range will be definitely from negative infinity up to the value of negative 1. Right, let's look at C. So you have y equal to x minus 2 in bracket squared, but you are given the value for your x, where x in between 0 and 5. Right, so when x 0, so y is 4. So somewhere here is your 4. So when y 0, x minus 2, 0. So x 2. Somewhere here. So you have the value for your x there. So when x, we found for x0 already here. So x5. So x5. So y equal to 5 minus 2 squared. So you get y equal to 3 squared. So 3 squared will be 9. So somewhere here 5. Right, it seems that the scale is too big. So let's make it smaller. So let's say this is your 4. So we need 9 here. So let's say this is 2. Right? And then we need 5. Somewhere here. Okay, this is the origin. So the x and the y. So this is how the curve would look like. So something like this. When it is 5, we get the value of the y to be 9. Okay. Now domain, definitely this. So that will be 0, 5. Range, so here to here, isn't it? So meaning 0, 9. So inclusive. Include the value. That's what I mean by inclusive. Right, look at D. Y equal to x squared plus 2x minus 1. So let's do completing the square first. So bracket squared minus bracket squared minus 1. So x plus 1. 1 here. So we have x plus 1 bracket squared minus 2. So the symmetrical will be at x equal to negative 1. So this is your negative 1. So when x is negative 1, y is negative 2. Okay, so when x is 0, so we get y to be negative 1 when x equal to 2. Okay, y equal to 2 plus 1, 3 squared minus 2, we get 7 when x equal to negative 3. So y equal to negative 3 plus 1, so negative 2 squared minus 2, so we have 2. Alright, so label your axis. So this is the x, this is your y-axis. So negative 1, 1, let's say this is 2. Negative 3, negative 1, negative 2, negative 3. Okay, so negative 1, this is negative 2. And then we have 7. Let's say this is your 7. When x is 2, it is 7. When x negative 3, so somewhere here, let's say 2. So now let's sketch it. So we have the minimum point. Okay, so the next part, something like this. Okay. So what is your domain? So domain definitely comes from here. So domain will be negative 3, 2. Range will be negative 2, 7. So from here to here. So this is your range. Right, cubic function. So look at the tips here. So if you have fx equals to ax cubed, so the shape will look like this when a is greater than 0. So when a is less than 0, so the shape looks like this. Okay, steps to sketch the cubic graph. Find the x-intercept when y0. Find the y-intercept when x0. Identify the positive and the negative graph. Okay, let's look at example 8. Sketch the graph of the function and state the domain and range for each of the function. So if you look at x cubed on the right here, the sign is positive. Fx here, it is also positive. So your y is actually your fx. Okay, so meaning the point starts with positive, positive. So let's sketch it. Okay, let's say this is your x and your y axis. Alright, so when x0, you get y0. So that will be your intersection point. So positive, positive will be somewhere here. So the graph passes through 0 going downwards. Alright? Okay. Domain of f, that will be negative infinity to infinity. So if you go along the curve, as it goes along the curve, it goes to the right. It goes to the right. Okay? So similarly, so the range will be negative infinity, infinity. Right, look at B. So now here x, the sign is negative. But here your y, your fx is positive. So the point will be negative, positive. So where is negative, positive lies? It should be in the second quadrant. Right? Negative value for your x and y. So x is negative, y positive, must be in the second quadrant. Okay, that's your y, this is your x-axis and the origin. So again, if you have x0, you get y0. Alright, so the curve will passes through the origin. So sketch nicely. And the domain will be negative infinity, infinity. Range also will be negative infinity, infinity. Right, look at C. Okay, next page, page 11. Okay, y equal to 4 minus x cubed. So this is negative x cubed plus 4. Y equal. So again, your x is negative, your y is positive. So meaning negative, positive. So this is for x and for y. So we have the axis ready here. So plus 4. When x is 0, so you get y equal to 4. So it passes through 4 here. So the point negative, positive in the second quadrant. So it goes through here. Alright, so this is the negative, positive. So this is your 4. Okay, so domain will be negative infinity, infinity. Range will be negative infinity, infinity. Right, what about D? Okay, you have y equal to 2x cubed minus 2x squared. So factorize 2x squared. So you get x minus 1. Right? So when x equal to 0, so you get y0. When y equal to 0, so you get 2x squared, x minus 1 equal to 0. So if you see here, you have x squared, right? So meaning your x squared 0, so get x0 or x minus 1, 0, x equal to 1. Then, if you look at this, your x is positive, your y is also positive. Okay, find the value for your x first. So this is 0, this is 1. So you have x squared. So there are two roots or two intercepts there, meaning the turning point is at x0. So plus plus, positive positive, the first quadrant. So it goes something like this. Alright, so the domain will be negative infinity, infinity. So the range will be also negative infinity, infinity. Right, next will be third function. So if you look at this, the diagram here, so here this is positive, positive. Here is negative, positive. Here is positive, negative. Here is negative, negative. We missed the bracket there. Alright, so if you have the function to be something like this, so this is where we get the x to be negative. So the front here positive, here positive, in front positive. This is for the y, this is for the x. Alright, so in the fourth quadrant, we have positive, we have negative, and both negative for the third quadrant. So that is the end point. Okay, so steps to sketch the third graph: define domain, determine the endpoint, identify the sign of x in the equation. Okay, the domain and range refer to the endpoint. Let's move on to page 12. Look at example 9. Sketch the graph of the functions and state the domain and range for each of the functions given. Right, A. fx equal to set x minus 2. So here, you see that this is positive. So this is also positive. Here minus 2, meaning it goes down by 2 units. Alright, so first things first, look at below the square root. So meaning there's only x there, so x should be greater equal to 0. Okay, can you follow? So when x is 0, so you get fx to be negative 2. So where is your negative 2? So this is your negative 2. Okay, so it goes up here to the right side because x to be greater equal to 0. So it goes to the right, towards right. So here this point will be positive, positive just now. Here. Okay, so the domain will be this. 0, infinity. So range will be, so from, if you look at the graph starts from here and up. So that will be negative 2 infinity. Next, look at B. So fx equals to set x plus 3. So it's just the same as A. The difference is only here plus 3. Okay, so again, this is positive. This is also positive. Can you follow? So here, since below here only x, so meaning x greater equal to 0. So plus 3 meaning shifting upwards with 3 units. So when x is 0, so you get fx to be 3. So find your 3. Okay, so the graph should look like this. So this is your positive, positive. So this is the origin. So domain of f, that will be 0, infinity. So range, what about range? So it starts from here, above. Isn't it? As the graph goes along here, so it goes upwards. Right? So meaning range will be 3, infinity. Yeah, the comma. Right, let's look at C. What about C? So we have fx equals to square root of x plus 4. So anything under the square root, so that will be x plus 4 to be greater equal to 0, x greater equal to negative 4. So for your information, this is actually your domain. So we have the domain already. But before that, so when x is 0, so we have fx to be set 4, which is 2. x0, fx 2. So here is 2. Okay, so the graph again, so here x positive, here x also positive. So where is negative 4? X negative 4 somewhere here. So the graph goes to the right. This is where we get the positive, positive. So this is your origin. So domain of f, that will be negative 4, infinity. So range of f, 0, infinity. Okay, D, similarly, those answer the those under the square root. So x plus 3 greater equals to 0, x greater equals to negative 3. So if you look here, this is negative, there's a negative there. The x here is positive, but this negative actually refers to the y. So meaning this is negative. Right? So when x is 0, so you have fx to be negative set 3. So where is negative set 3? Somewhere here. This is negative set 3. Okay. Right, x negative 3, somewhere here. So, where is the point positive, negative? Which quadrant? Positive, negative. This is the fourth quadrant. Somewhere here. So, we are going to, okay, so sketch it. This is the point positive, negative. So, domain of f starts from here to the right. Starts from here to the right. It goes to the right. Okay, so that will be negative 3, infinity. So range from here downwards, isn't it? So meaning, what do you get? So from negative infinity to 0. Right, next look at E. So we have fx equal to square root of x plus 1 plus 2. You have plus 2 behind here. Alright, so x plus 1 greater equal to 0, x greater equal to negative 1. That will be your domain. Okay, so again, your x is positive, your y is positive. Right, so when x is 0, so you get fx equal to third one, meaning 1 plus 2, you get 3. So get your 3. Okay, so get your negative 1. So here is negative 1. So it's not the same scale. Something like that. Alright, so plus 2. This 3 should be more, something like this. Okay, if without the plus 2 meaning going upwards with 2 units. So without 2, it starts from here. But now if plus 2, it goes to here. So it starts here. This is 2. So the graph would look something like this. Okay, that's the point. Negative 1, 2. So here, this is the positive, positive. So this is the origin. So domain of f, you will get negative 1, infinity, range of f. So starts from here, upwards, isn't it? So meaning 2 to infinity. The 2 is included because we have equal sign. Right? Right, let's look at f. Fx equal to square root of 1 minus 3x. So under the square root, we have 1 minus 3x. Okay, so 1 minus 3x greater equals to 0. So we have 3x less than equal to 1, x less than equal to 1 over 3. So where is your 1 over 3? Somewhere here. Okay, next we look at the signs of the x. So this is negative. So this is positive. So that will be negative, positive. So where is negative, positive? That will be in the second quadrant. Isn't it? So when x is 0, so what do we have for your fx? So x 0, so we get fx to be 0. 0. So not to forget, we have minus 1 here. So if we don't have any minus 1, so it will start from here. But now when it is minus 1, we're going to shift downward by 1 unit. Goes down by 1 unit. So let's say this is your negative 1. So it passes through the origin. So the graph would look like something like this. So this is where we have the negative, positive. So domain of f, that will be negative infinity 1 over 3. Range of f, that will be from here upwards. So that will be from negative 1 to infinity. Right, reciprocal functions. Okay, so if you have fx equals to 1 over ax, so if a is greater than 0, so we will get the shape to be like this. Okay, on the right side, on the left, the positive part, so this is the negative part when a is less than 0. So before we do example 10, so steps to sketch a reciprocal graph: identify the asymptote, horizontal or vertical asymptote, find x and y intercept, shape of correct graph. So if you have y equal to 1 over, let's say, x minus a plus b, so this is the secret. So this is where you get the so you will get it from here. There's x minus a 0, so x a. So this will be your vertical asymptote. So this is how you get it. And here, this part b. So this is where you will get your horizontal asymptote. So for this case, y equal to b. So we're going to apply that. So let's look at example 10. Sketch the graph of the functions and state the domain and range for each of the functions. So if you look at a, y equals to 1 over 2x. So notice that here plus 0. So the denominator, so 2x, it cannot be 0. So this is how we start off. So x cannot be 0. So meaning the vertical asymptote here will be the x equal to 0. Hence, the horizontal asymptote will be this part here 0, so y equal to 0. So let's sketch. Okay, so before we sketch, we look at the symbol of the x. So x positive, this is also positive. So let's use it. Okay, x0, y0. So x0, so this is your vertical asymptote, x0. Okay, so let's write it nicely. So this is your horizontal asymptote, which is y0, right? So the x is positive, the y is also positive, so it should be a positive graph. Right? So the domain will be real number except 0. So range will be real number except 0 also. So this is one way of writing the domain and the range. Right, let's move on to B. So you can see here clearly you have the negative there. So again, behind here is plus 0. Okay, so we start off with the denominator. So x cannot be 0. Right, so vertical asymptote will be x0 then. So horizontal asymptote comes from here. Again, y0. Okay, so you need to label your asymptote. So this is your vertical asymptote x0. Here is the horizontal asymptote y0. Okay. Since you have the negative there, so meaning the graph should be somewhere here. Okay. So the domain will be again real number except 0. Range will be real number except 0. Okay. Right. Next page. Page 14. So this is the last page of the first lecture. So C, you have fx equal to 1 over x minus 3. So notice that we have minus 3 there. Okay. So again, so the denominator x. So x cannot be 0. So that's where we get the vertical asymptote. So x0. Horizontal asymptote, I told you, you have the negative 3 there. So y equal to negative 3. So find your y negative 3 somewhere here. This is y negative 3. Okay, label your line. x0, so this is your x0. Okay, you look at your x is positive, fx is also positive. So let's get the intercept. So can we get the intercept if x 0? So that's not applicable. If y, fx 0. So if fx 0. So 1 over x minus 3 is 0. So 1 over x equal to 3. X equals to 1 over 3. So we have 1 over 3. Somewhere here. Okay, the shape must be the same when x positive, y positive. So this is your 1 over 3. So you don't have any y-intercept. Right? So the domain of f will be the vertical, except the vertical. So real number except the vertical. The vertical is vertical asymptote, except 0. So range of f will be real number except the horizontal asymptote, which is negative 3. Is it okay? Right, D again. So you have gx equal to 2 minus 3 over x. So rewrite it in that format. So that negative 3 over x plus 2. So again, you look at this part and this. Right, you need to write x cannot be 0. So that's where you get the vertical asymptote. So x 0, horizontal asymptote y equal to 2. Okay, when fx 0, so 2 minus 3 over x 0, 3 over x equal to 2, sorry, so x equal to 3 over 2. So first, you need to find your vertical asymptote and then your horizontal asymptote. So label, this is x0, here is y2. Find your x3 over 2. So somewhere here. Okay, so the graph should look like something like this. You have a negative curve, negative sign there. So that is your 3 over 2. So this is your origin. Hence, domain of G will be, I told you, real number except the vertical asymptote, which is 0. Right, range of G will be real number except the horizontal asymptote, which is 2. Right, so let's look at E and F. Okay, give a good guess. So look at the denominator and then look at this. So the denominator, x plus 2, cannot be 0. Why it cannot be 0? Because it's in the denominator. So x cannot be negative 2. So hence vertical asymptote, x negative 2. Horizontal asymptote, y equal to 1. Right? So then you look at the x positive. Okay, fx also positive. So find your negative 2. So this is x negative 2. y1. Okay, y1. So when x is 0, so we can get when x is 0 now. Okay. So we get fx to be 4 over 2 plus 1. So you get 3 when fx is 0. So intercepts 4 over x plus 2 plus 1 equal to 0. So do you know how to solve this? So 4 over x plus 2 negative 1. So you just change place. So you get x plus 2 equal to negative 4. So x is negative 6. So this is where you get your negative 6. Right? So you get your fx to be 3. So somewhere here. So the curve will look something like this. Okay, make sure it doesn't touch the asymptote. Right? So next, domain of f, real number except the asymptote, negative 2. So range, real number except 1. Right, similarly for f, so you look at the denominator and the number beside. So x minus 3 cannot be 0, x cannot be 3. So hence vertical asymptote will be x3, horizontal asymptote will be y2. So draw your vertical asymptote, 3, y2, this is your y2. Now you need to get the intercept when x0. So fx to be what? 5 over 3 plus 2, 3 to 6, 6, 5, 11 over 3. When y0, no, fx 0, not y, fx 0. So meaning negative 5 over x minus 3 plus 2 equal to 0. So 5 over x minus 3 equal to 2. So 5 over 2 equal to x minus 3. So x equal to 5 over 2 plus 3. Plus 3. 3 to 6, 6, 5, 11. So 11 over 2. So that is the value for your x. Right? So x 11 over 2. Y, what's the value just now? Fx, x over 11 over 3. Alright, so you have a negative sign there. So the curve will look something like this. So prolong the x-axis and the y-axis. So this will be your 11 over 3. And this is your 11 over 2. So domain of f, real number except 3. Range of f, real number except 2. Done.